Morning.
Morning, Joe.
Morning.
Uh, Joe,
Yes?
for our online exam, Joe,
Hmm.
are you going to give us an open book test?
Uh, no, I'm not sure lah. But I guess it's more of like I give you the exam, and then however you do it, it is up to you in the sense that if it's an open book exam, then will it help you to see how good you are at the topic? So it really depends on how you choose to do it lah. Because we cannot stop you from looking at the book because we're not there, right? So it really depends on your own conscience lah, and what you want, how you want to do it basically. Because if we say okay, no open book test, but we can't make sure that there is no book, you see, like in front of you.
Joe, but then there is but then will you be giving us open book, or will you say we can't use the book?
I personally will say don't use the book lah, but whether you all use or not, that is between you and yourselves, I guess. But for me personally, I will not make it an open book test lah,
Why? So please, Joe, you need.
especially for like maths. But then I don't know. I'm still waiting for
So,
the
but
school
then
to tell us how to go
maths you
about
can't
it.
really make it an open book, but it's just based on your own knowledge of maths.
Yeah lah, exactly. No, because I mean, I guess at the end of the day, it's like it's you can refer to a book if you want to, but by referring to the book, will you gauge how much you know about the topic or your understanding of what I've taught so far? You know what I mean? So yeah. See how lah. Did you all receive any email yet?
Not
No.
yet, Chef.
Okay. Let's start. I'll just quickly take attendance. If you're here, please say you're here, and then we will start. Okay. Isaac. Is Isaac here? Yes. Okay, Isaac is here. Isabel. Oh, Isabel's not here. Abigail. Abigail not here. Carlos. Carlos, are you here? Not here. So, Elijah. Oh, Carlos is here. Mic not working. Okay. Elijah.
Here, Joe.
Okay. Kavishka.
Teacher.
Ricardo.
Theater.
Pooja. Oh, Pooja is here. Sureka. Yeah. Aaron Look. Not here. Zarit. Not here. So, Michelle. Malcolm, Jared is here. Judith, so not here. Why are all your friends absent? Your class, Asher, this whole week attendance very bad. Do you all know why? What happened to all your friends?
So not sure.
I think some of them had connection problem or something.
Connection problem?
I think so lah.
Okay, Celeste also not here. Okay, Abigail, Isabel, Surika, Aaron, Lok, Zari, Michelle, Malcolm, Judith, Celeste not here. Anyone I didn't call? Okay, all here. Okay, let me just quickly put this in the group and then we can start. Okay, so can everyone see my screen? My slide on Pythagoras theorem?
Yes,
sir.
Okay, so last week we did angles in circles, but there are two more rules we have to look at. But before we look at the two rules, I want us to look at Pythagoras theorem first, because after we learn Pythagoras theorem, it will help with the other two rules in for the circles, angles in circles. So we'll jump a bit to Pythagoras theorem, finish this up really quickly, and then we'll go back to the last two rules in the angles in circles. Okay?
So we're gonna learn the two rules today itself.
Yes, because Pythagoras theorem is not very long.
Okay.
It's not a lot. So I will do Pythagoras theorem, and then we'll do the last two, which is the last two circle theorems, because that part of the rule has to use Pythagoras theorem. So I'll go through this first. Okay, so please make sure you need your calculators, and then your pencil, your ruler, because got drawings as well. Okay, and your pen and everything. Okay, so yeah, let me just post the attendance in the group and then we will start. Okay. Okay, so Judith is in. Judith, are you here?
Yes, Chair.
Why are you late?
I just woke up, Chair.
Next time, please don't be late.
Yes, Miss Sharina.
Okay, Celeste, why are you late? Celeste, can you hear me? Okay, let's continue. Okay, yeah, so like I said earlier, we'll look at Pythagoras theorem and then we'll go back to the last two rules for angles in circles. So this is the guy, his name is Pythagoras, so he named the theorem after him. So he looked at, he came up with a theorem specifically for right-angled triangles. Does anyone know what right-angled triangle is? You should know by now, but what is right-angled triangles?
A triangle
Right
has
angle in
180
it.
degrees.
A triangle that has what?
The triangle has a right
Triangle
angle
has a
in
right
it.
angle.
What is right angle? How many
90
degrees?
degrees.
90 degrees. Okay, so right angle triangles are, for example, like this. One side is 90 degrees triangle, 90 degrees. Okay, so what is Pythagoras theorem? Okay, so he said that for any right triangle, okay, look first, I'll give you time to copy. For any right triangle, the sum of the areas, okay, listen, the sum of the areas of the two small squares, okay, so if this is A, that means the square beside it will be A square, because square both sides are the same. And then the second biggest one, the second smallest one is B, will have area B square. Okay, when you sum both of them together, it will equal to the area of the larger triangle. Okay, why is this the largest triangle? Because C is the longest side. Okay, longest side is known as hypotenuse, and it's always directly opposite to the 90 degrees. So if you see here, this is 90 degrees, and then directly opposite is the hypotenuse. The hypotenuse here is C, and the hypotenuse is always the longest side, which means the square on the C will be the biggest. Okay, So
Yeah, this only works for right angles.
yes, this only works for right angles. Okay, so again, let's see. For the right triangle, the sum of the areas of two small squares is equal to the area of the largest square. So a square plus b square, when I add them together, I will get the area of the third square. Okay, so can you please copy this down quickly? Please draw the triangle as well and the squares and write it down, write everything down. So write there Pythagoras theorem. You don't have to write the first one lah. So what is Pythagoras? He said that. Just write Pythagoras theorem, draw this diagram, and then write the definition and the formula. Okay, those who are still copying, can I please see a raise of hands? Okay, keep copying. Give you all another 2 minutes. Okay, can I move on to the next one?
Yeah.
Yeah, can I? Okay. So we can use Pythagoras theorem to find the longest side in a right angle triangle. So longest side being the hypotenuse, which is opposite the 90 degrees. Okay, so using the formula, we square the other sides first. Okay, we square them. Why are we squaring them? It's because we want to get the area of those the squares. If I were to put a square here. Okay, so for example, okay, so let's say I were to put a square here. And a square here. Okay, so the area will be 3 times 3, which is
9.
and here will be 4 times 4, which is
16.
16. So 9 plus 16 is
25.
25.
5. So what square is 25? What term?
5.
5.
5.
Which means x is 5.
5.
Okay.
That means we square root the answer. Je.
Yes, you square root the answer. Okay. 25. So x will be, you square root it. So square root of 25 is 5. Okay. So you don't have to write down everything. Just draw the triangle in the middle here. Okay. And then you just write 3 square plus 4 square equals to x square. And then you do the calculation to find x. You don't have to copy all this down. Just draw the triangle, label 3, 4, and x, and then you write down how to find x. Okay? I'll give you a couple minutes to copy.
Yeah.
Yes? Yeah?
You know the formula is a squared plus b squared equals c squared, right?
Yes.
So wouldn't it be 25 squared because of c?
So c square is 25.
Oh, it's not 25 squared lah.
No, no, no. Something square is 25. So that something is 5. Okay, anyone still copying? Please raise your hand. If not, I'll move on to the next one.
Yeah,
Oh, still copying. Okay. Give you all 1 minute more. Can we move on to the next part?
Yeah.
Yeah, okay. Okay, so let's look at this. Find the length of side X. Okay, can you all try first? Draw the triangle. No need to write those things down. Just draw the triangle and try to find X. And then we'll discuss in a while. Okay, what do you all get?
11.402.
11.402. Anyone else got any other answer? No? Okay, let's see. 9 square and 7 square. 81 and 49, I add them together, I get 130. So x square is 130, x is square root of 130, which is 11.4 cm. You can take one decimal, please. It's good enough, okay? Okay, anyone don't know how to do or don't know how I got or don't know what's happening on the slide?
Miss Shaina, I don't know how to do the X one.
Okay, yeah, because you went out just now, accidentally. Okay, so basically, I have a triangle, okay, like this, okay, and then X is the longer side. The longer side is hypotenuse, which is opposite of the right angle triangle. Okay, so if we look at the previous slide, a square, that means this side squared plus this side squared will equals to this side squared. Okay, so which means 7 square. So I add, to find x, I square both sides first. Okay, so I square the 7 and I square the 9. So 7 square is 49, 9 square is 81. And then I add both of them together, 81 and 49. 81 and 49 is equals to 130. So x square, the one that we're finding for, x square is 130. X is equals to square root of 130, which is 11.4. So that's how you find the hypotenuse side.
Okay.
Okay?
Yes.
Okay, I'll give you some time to copy. Okay, so this theorem works for So why I said we wanted to look at this before we look into the last two rules of circles is because in circles also there will be right angle triangle, and you might need to use this rule to find certain length sides, the length of certain sides, which is why I wanted to look at Pythagoras theorem first before we go to the last two rules. Okay. Okay, Zarib, are you done copying?
Almost. Done, Miss Shaina.
Done? Okay. Okay, next one. I have 4 cm and I have 8 cm. What would x be? Okay, try and do.
Sure, got 8.9, sure.
Okay, anyone else? Someone wanted to say something? No. Okay. So one answer is 8.9. Okay. Let's wait for the rest. Anyone got any other answers?
So I got 8.9.
Okay, 8.9 also. Let's see. So I square both sides. So 4 square and 8 square, which is 16 and 64. And then I add them up. When I add 64 and 16, I get 80. So x square, this side here, the square of that is 80. X is square root of 80, which is 8.9 cm. Okay, don't forget the cm. Anyone
Sure,
got
must
different
you
answer?
Sure, must you draw this down?
No, son, if you never write, it's okay. As long as you have one example, 1 or 2 examples, it's fine.
Yeah, got 8.9.
8.9. Okay, let's look at the next one. Example 3. Okay, now it's a bit different. Now we have the side, the shorter side, which we don't know. So again, we use the formula a square plus b square equals c square. Now my a is x, my b is 7, and my c is 12. So 12 square is 144. 7 square is 49. So now I subtract, because now I'm given the longer side. So the longer side minus the square of the shorter side is 95. And then square root of 95 is 9.7 cm. Can?
You can copy this.
Yes, please copy this down. So when you're given the longer side and asked to find the shorter side, then you subtract. Yeah, you all done copying?
Yes, sir.
Done, sir.
Yes.
Okay, so I'm just going to show you the screen, the whiteboard, because I want to show you another way of doing it. Okay, so let me just open the whiteboard. Okay, so can you all see the whiteboard?
Can, sir.
So another way of doing it is okay, we have a triangle, and we have 7 cm, x, and 12 cm. Okay, so we know that a squared plus b squared equals c squared. Okay, c squared is always the longer side. Okay, the c squared is always the longer side. So which means, as in the c. So this is c, this is b, this is a. A or b can be anything, can be either way also. But c must always be the longest. So if I were to put the values inside this formula, okay, a is x. So x squared plus b is 7. 7 squared. C squared, c is 12. So 12 squared. And then x, I don't know. 7 squared is 49. 12 squared is 144. 12 times 12, 144. Okay? 144. Yeah.
Yeah, sir.
Then I move this to the other side. 144 minus 49. So x squared equals to 5, 6, 7, 8, 9, 5,
95, sir.
5,
95.
95. Okay, and then x is equals to square root of 95. This is the other way to do it by using the formula. Okay, square root 95 and then square root 95. You find out, you plug in your calculator and then you should get the value. Okay, in this case it will be 9.7 cm. This is another way of doing it by using the formula itself. Okay. Okay, can you please quickly copy this down? Just this way of doing it.
So can you move the board a bit back? We can't see the full board. Okay, sir.
Okay, all done. Anyone still copying? Raise your hand. Okay. Oh, okay, still copying. Okay. Okay. Okay, all done? Yes?
Done, sir.
Yeah, done.
I'm going to switch back to the slides. Okay, so this is what we looked at just now. Anyone had any questions so far? No questions. Okay. Let's look at the next one. Okay, now try this one.
So we can give our answer in mm or cm, right?
Yes. Okay, this one also similar to the previous one. They've given you the longer side, which means you have to subtract. You can also use the formula like how we did on the board just now. Okay, so try and calculate.
Check, it's 17.43, sir.
17.43. Any other answers?
So 17.4.
Okay. Let's see. I square the ones given to me, and then I subtract. I should get 304, and then I square root 304, I get 17.4 cm. Okay, so when you're doing Pythagoras theorem, the first thing you need to do is you need to identify which is the hypotenuse, which is the longer side. The longer side is called hypotenuse, okay, which is the C. So how to find which is the C? You look for the 90 degrees first. The moment you find the 90 degrees, okay, the moment you find the 90 degrees,
So I got 17.4 mm, not cm.
oh yeah, mm, I think it's a mistake here, it should be mm. Okay, so the moment you find 90 degrees, you look for the opposite side of opposite to 90 degrees. That will be the C, that will be the longest side. So that is how you find your hypotenuse. Okay? Anyone got a different answer? This should be mm. Okay, let me just quickly change it. Okay. Okay. Okay, for each of the following triangles, calculate the length of the missing side, giving an answer to one decimal place when needed. So there are 6 questions here. Quickly do. You don't have to draw the triangle, but you can do your working and then do all 6, and then I will give you all the answers. Okay, then we'll move on to circle theorem.
Done, sir.
Okay, let's just quickly see. I'm gonna put the.
Done, sir.
Anyone don't know how to do any of the questions? Okay, let's look at the answers. You should get these answers. So just check your work. If you got any of it wrong or you're not sure why it's different, please ask me. If not, I will go on to the next.
Sir, for the first one, I wrote 6.71.
So the question says, give your answer to one decimal place. So only one, just take one decimal place.
Also, for 5 also I wrote 1.01.
So you take one decimal place.
So it's necessary to write the 1.0.
Yes, because it says decimal 1.01. So you just put 1.0 lah. Because 1.01 is not equals to 1. So you cannot just put 1. Although one decimal place is 1.0.
Hmm. I got it.
Okay, anyone has any questions? Okay, wait. Just give me a second. Okay, how did you get question 1? Okay, question 1, I add both the short sides. So 6 square is 36, 3 square is 9. 36 plus 9 is 45. And then I square root 45, I get 6.7. Okay. Celeste, you got 17.4 for which question? Okay, just give me a moment, yeah. Okay, let's see. Previous question. Okay, let me just go back. Previous question, 17.4. Yeah, correct. The previous question is 17.4, Celeste. That's correct. Okay. So I have another question on the chat asking if you'll be allowed to use calculator. I can't remember which paper allows to use calculator. I will let you all know again. We will be sending out revision topics soon. So just please be patient a bit when it comes to exams. Once the topic for the exams come, then you can ask me all the questions you want. Because right now, I really don't have a lot of answers, okay? So just be patient and wait for the exam results to come, topics to come in. Okay, question 2. Someone asked question 2. So how do you do question 2? Anyone want to explain? How to get 9.8? Okay, Carlos, did you get question 2 right? Okay, not answering. Judith, did you get the question 2 right? Sorry?
Sorry, Chen. No, I don't think I got question 2 right.
Okay, Kavishka, did you get question 2 right?
Yeah.
Okay, can you explain how you did question 2?
So you take 11 times 11, you
Okay,
get
11 square. Yep.
121.
Yeah.
Then 5 times 5, you get 25.
Yeah.
So 121 minus 25, you get 96.
Yep.
Square root, you get 9.7.
9.79, so which is 9.8. Okay, so you take the longer side, 11 square, minus the shorter side, 5 square. So just remember, if question 1, where you have to find the longer side, you square each of it, you add them together, and then you square root the answer. For question 2, where you're given the longer side and you're asked to find the shorter side, you take the longer side, you square it, and then you minus the square of the shorter side, and then you square root the answer to get the other side. Okay, Pooja, can I understand? Okay. Okay, then should we do it? Okay, so I'll put questions on at Modular. Okay, so that is all for now. This is Pythagoras theorem. So now it's 9:58. You can go and take a quick break. Come back at 10:10. Okay. 10:10. Come back at 10:10. 10:08. Now it's 58. 10 minutes. Come back at 10:08. Okay. Okay, is everyone back?
I'm back.
Okay. Okay, let's go on to quick for that. So this is what we looked at just now. Okay, very quickly, I just want to show you all this. Calculate the length of the diagonal of this square. Okay, so diagonal. So we know that a square has same side. So this is 6, this is 6 as well. So how do we find this? This is the isosceles lah. So 6 square plus 6 square, so 36 plus 36 is 72. And then square root of 72, I get 8.5 cm. Okay, if a right angle has short lengths, 14 and 8, what is the length of the longer side? So 14 square plus 8 square, and then I square root that answer, and then I get that. Okay, while we are doing, have your calculators with you and try doing as well.
I can explain number 7, Ajay.
Sorry?
Okay, can you explain number 7 again?
Number 7 basically is just, I have a square. Square means both sides are the same. I mean, all sides are the same. So if this is 6, this is also 6. So the diagonal will be the hypotenuse, which is 6 square plus 6 square, which is 72. And then I square root 72, I get 8.5.
Okay.
Okay.
Just the answer for 912.6.
Wait, we'll go through it. Calculate the height of the isosceles. So the height is this line here. So when I draw a straight line from the point to down, this automatically becomes 4, 4. It's half lah. So now I have, let me just take a pen. So I have, this is 4, okay, and this is 12, and this is the right angle, this is the longer side. So the height is this one here. So how do I calculate the height? I take 12 square minus 4 square is 128, and then I square root that. I should get, what do I get? Anyone got any of it? Anyone got anything? What do you all get once you calculate? What did you get, Jared?
So basically it's 144 minus 16 lah. And then you square root it.
144 minus 16, yes.
So 11.3.
11.3, yeah, correct. Wait, my mouse is, the mouse on my laptop is not working. Just give me a moment. Okay. Okay. So, should get 11.3. And then the last one, calculate the base of the isosceles.
12.
So I've given 10 and 8. So the base is 10 square minus 8 square.
12.
12.
Yeah, I got 12.
Yep. So the base will be, so this, if you take 10 square minus 8 square, you get this side to be 6. But they want the whole base, so you add another 6, so you get 12. Okay? Anyone has any questions?
Not sure.
Okay, so just remember at the top here, you see, longer side, you add to find the longer side. For shorter side, you subtract. You take the longer side minus the shorter side. To find the longer side, you just add the two shorter sides, the square of both the short sides. Okay? So that is for this part. Okay, wait, I have a question on the chat. Okay, so I'm going to explain number 10 again. So I have, okay, so this is 10. This is 8. This is a right angle triangle. Find this one first. Because they say the base is the whole thing, but I calculate this one first. So if this is a right angle triangle and I have the longer side and I ask to find the shorter side, I take the square of the longer side, which is 10 square, which is 100. And then I minus with 8 square. 8 square is 64. 100 minus 64 is 36. Square root of 36 is 6. And then this side is 6, this side is also 6. So the whole base is 12. Puja can understand? Okay. Okay, so let's go to the next part, which is the circle theorem. Okay, anyone has any questions on Pythagoras theorem?
Not sure.
Not sure.
Okay, it's quite straightforward. Okay. So let's look at the third and fourth theorem. Okay, everyone can see this? The next slide? Yes?
Sure.
Yeah.
Yeah.
Okay, get ready make sure you have a circle, a coin or something with you. A circular thing so that you can draw the circles like last week. Okay? Okay, let's start. Okay, circle theorem. Okay, starter. A man walks 15 kilometer due east and then 10 km due north. How far is he from the starting point? What bearing is he now at from his starting point? Okay. What bearing should he travel along to walk directly back? Okay, this one we'll look at later lah. We'll look at the theorem first. Okay. We're looking at bisectors of chords. Okay, so a chord is a line joining 2 points on the edge of a circle. So for example, like this, it's a chord. It splits the circle into a major segment and a minor segment. Major segment is the bigger segment, minor segment is a smaller segment. Okay, so for example, like this, major, minor. The diameter is a special chord that splits the circle into exactly half. The diameter is the one in the center. If it's not in the center, but it's a line, then it's called a chord. Okay, quickly copy this down. Okay, can I have a show of hands of those who are still copying? Okay, keep going. I'll just explain one more time. So I have a chord. A chord is a line joining 2 points on the edge of a circle. So when I have a chord, I will divide the circle into two segments, a major segment and a minor segment. Major segment is bigger and the minor segment is smaller. Okay, and then the diameter is when it's a chord, but then it divides the circle into exactly half. So when I have a line in the circle and it divides the circle into exactly half, then I call it a diameter. If not, it will be called a chord. Okay, let's move on to the next one. Okay, so now the perpendicular bisector of a chord is the line that cuts it in half. So if you remember what we learned when we're doing constructions, perpendicular bisector is a line that cuts another line into half. So perpendicular bisector of a chord is the line that cuts it into half. And the other thing about perpendicular bisector is it will cut it in a right angle. So if I have a line like that, it will be 90 degrees. Okay, it always goes through the center of the circle. The perpendicular bisector will always go through the center of the circle. Okay, always. Okay, okay, please copy this down. You can just copy one, you can just draw one circle, but copy both the points. Okay, anyone still copying, or can I go to the next part?
Still copying, sir.
Copying, okay. Okay, let's go on to the next one. Okay, let's look at this. AB, this is an example. AB is a chord in a circle with O as the center, and it makes a triangle. The radius of the circle is 5. Radius of the circle 5, and AB measures 8. That means the chord is 8 cm. Calculate the distance OM. So OM is now a perpendicular bisector because the line is going through the center, and that's what we looked at in the rule just now. So OM splits the triangle OAB into half. Okay, so if we were to take out this triangle, okay, we know that OA is 5 cm because that's the radius of the circle. OA is the radius. AM is 4 because AB, the whole thing is 8, so half of it is 4. Why half? Because it's it has split the chord into half. So what is the missing side? This is where we get Pythagoras theorem in. So I take 5 square minus 4 square, and I should get A equals to 3. Okay, can I understand? Anyone has any questions? Okay, if you have no questions, please copy this down. Copy all of it down.
The whole thing, Acha.
Yes. Okay, for this question, you don't have to actually draw the perpendicular bisector with the protractor and the compass. You just draw like a normal circle and just cut a line down. And then to denote that it's a perpendicular bisector, you just put the 90-degree sign there, so that when you do your revision, you will know that it's a perpendicular bisector. Okay.
So must we copy the entire question now?
Yes. So that you know what the question is. Okay, so what you want to remember is a perpendicular bisector will bisect a chord into exactly half, which is why I say AM is 4, because AB is 8, so half of it is 4. And then the radius is 5. How I know OA is a radius? Because O is the center of a circle. So any line from the center of the circle to the circumference will give me the radius. And then I use Pythagoras theorem. Okay, can I see a show of hands of those who are still copying? Okay, keep going. I'll give you all another 1 minute. Okay, let's continue. Okay, so this one no need to copy. Just look at the question. Okay, so the line OM is the perpendicular bisector of the chord CD. OM is 3 cm long. The radius is 13. How long is chord CD? Okay, I'll give you a couple minutes to think about it, and then we will see what the answer is. You don't have to copy it down, just look at it and try to figure out how long is the chord CD.
So you must copy the question, Richa.
No. Okay, anyone has any answers? No? No answers? Okay, let's see. OM splits the triangle OCD in half. Okay, so if I were to take half the triangle out, I have something like this. And then we know that OC is 13 cm because that's the radius. We know that OM is 3 because that's given. So what is cm? So I take 13 square minus 3 square, and I should get 12.65 centimeter. Okay?
Sorry, I was muted. The whole of CD is 25.298222128.
Say again.
The whole of CD is 25.298222128. And then I just put it to the first decimal place, so it's 25.3.
Yeah, correct. So cm is 12.65, but I want the whole of CD. So it just times 2 lah. So 25.3 cm. Okay? Okay, so that's it for this. And then we'll look at the last rule. Okay? The last rule. Okay, so very quickly, let's see if you can remember what we learned so far. What are the missing angles? A and B.
So B is 272. A
Okay,
is
how do you get
44.
that?
360 minus 88.
Correct.
And then A, I got 44.
How do you get 44?
88 divided by 2.
Correct, half of 88. Okay, and B is 272.
So do you have to copy all this
No,
down?
no need. This is just a recap from last week's class. Okay. So now we look at the last one where we have the diameter we looked at just now. Chord we looked at just now. We divide into minor and major segment. And then the third one we're looking at is tangent, yes?
So you know the second circle, actually, I mean there are 2 minor segments and 1 major segment for the chord.
Yes.
Okay.
And then the third one we're going to look at is, the last rule we're going to look at involves a tangent. Okay, so if you look at a tangent, A tangent is a line that touches a circle at one point only. Okay, so it's not like that because this is 2 points, one here, one here. It's not like that because it doesn't touch the circle at any point. Okay, a tangent is like this. You see, it touches at one point. It touches at one point. It touches at one point. Okay, so these are tangents. So quickly write down this definition first. You can just write down the second sentence. A tangent is a line that touches a circle at one point only, and then you can draw the second circle with the tangent lines. So write down the second sentence and then the second circle. Draw the second circle. Okay, can I have a show of hands of those who are still copying? Okay, I'll give you all another 1 minute. Okay, let's continue. Okay, a tangent is perpendicular to the center of a circle at the point of contact. Okay, so which means if I have a tangent and if I have a perpendicular bisector to it which goes through the center of the circle, it is 90 degrees. I have a tangent, I have a line that hits the tangent and goes to the center of the circle, it is 90 degrees. Same thing here. So this is the fourth rule. A tangent is perpendicular to the center of a circle at the point of contact. So please copy this rule down and then you can draw one of the circles and label 90 degrees. So this is the last rule we are looking at for today. Okay, anyone still copying? No. Okay, let's move on.
Okay.
Still copying?
Yeah,
No?
I have copy.
Oh, done already. Okay, let's continue. Two different tangents drawn to a circle from the same point are equal in length. So I have a tangent here because it touches here and touches here. And if they go to, if they meet at a point like this, it is 90 degree because remember just now the rule, if I have a line, this is the tangent, that means it's 90 degree. So same here. This is a tangent, 90 degree. Okay. So they will be of equal length. Same thing here. They will be of equal length. This will also be equal length because it is the radius anyways. So this is equal because it's the radius. But these two lines will also have the same length. Okay, please copy down. Okay, these rules are all very important. Like I said in last week class, when you have a circle, the first thing you want to do is you want to remember all the different rules and what rules can you apply to the circle. And then you find the angles, you find the length and all these things. Okay, can I have a show of hands of those who are still copying? Okay, still copying. Give you all another 1 minute. Okay, let's move on. Clear this. Okay. What are the values of angles A and B? So if we look at this, angle A, the triangle is isosceles. Okay, which means we know that both the sides are the same based on the previous statement. Okay, which means both A and the other side is going to be the same. And we know that a triangle is 180 altogether. So we take 180 minus 50, we get 130, then I divide it by 2. So A will be 65. Okay, anyone doesn't understand this part?
Isn't it supposed to be 90 degrees?
Which one?
The A.
Why 90?
The rule says so, right?
The tangent has to go to the, this whole thing is 90.
Huh?
Let me show you. Wait. This is 90. The
Oh,
tangent
okay, okay.
to the
It
center,
has to cross into the triangle.
into the center of the triangle and center of the circle.
Okay.
Okay?
It means if you wanted to find B, you just minus 90 with 65 lah.
B, yes, correct. Okay. Wait, the mouse is not working again. Just a moment. Just a second. Yeah. Okay. So 65, 65. Okay, angle B will be, the tangent is 90 degrees. So 90 minus 65, B is 25. Okay, everyone got that? Can understand? Or anyone has any questions or don't understand? No, okay. Again, we look at another example, calculate angle X and Y. So we know that angle X, the tangent is 90 degrees. That means this whole thing here, according to the rule, this whole thing is 90 degrees. Okay, so which means X is 90 minus 38, which is 52. So X is 52. Okay, and then angle Y. The two missing angles in the lower triangle can be worked out. Okay, I take 90 minus 71 to get the other one. And then this angle plus this is 180 because it's a triangle. So I take 180 minus 48 minus this, I will get this part here. Okay, so this is 90. And then 180 minus 48 minus 19 is 113. And then I use 180 because Y and this is a straight line. So I take 180 minus 113, Y is 67. Okay? Okay, everyone okay so far? Anyone has any questions? No. Okay. Okay, we look at another one. The diameter of a circle with center B is 10 cm. So the diameter is 10 cm, the radius is 5 lah. The tangent from A to the circumference, so tangent from A to the circumference is 14. Calculate the distance from A to B. Okay, so I know A to the circumference is 14. The other side is also 14 based on the rule, and I know the radius is 5. So calculate the distance from A to B. That is what I want to calculate. So this, I use Pythagoras theorem because this is a right angle triangle here. So I just take 14 square plus 5 square. and then I square root 221, I get 14.87. So AB is 14.87 cm. Okay, anyone has any questions?
No, sir.
No, all okay, huh? Okay, so this for this topic especially, the more practice you do, the more you get the hang of all the rules, the more you're able to see all these hidden rules in a circle. Okay? The angle between a tangent and a chord is equal to the alternate segment. So if we look at this, we have a tangent, we have a chord, the angle here, and there is the same. Okay? I have a chord, this angle, and the opposite is the same, the alternate segment. Same thing here. Okay? Okay, so please copy this one down. This is a small rule that connects tangent and chord. So write the rule and copy down one of the circles. The angle between the tangent and the chord is equal to the angle in the alternate segment. Okay, can I have a show of hands of those who are still copying? Okay, let's go on. Okay, so these are what it means lah. Okay. Okay, work out the two missing angles. So from the previous rule. Okay. I have A is 79 and then B is 71. Why? Because this angle here. This angle here is 71, which corresponds to this alternate angle here. So it is 71. So B is 71. Okay. Okay. So if I have this, let's look at it. Angle A is here. Okay. So based on the rule, angle A is 55. Okay. Remember the center is there. And then I have angle B. Angle B, we know that the whole thing is 90 degrees. Okay. So 90 minus 55 is 35. Or we can also do angles in triangles. And then we have angle C. We see the alternate again. It's the segment from the previous slide, so it is 13. Okay. Okay, which angles will be 72 and which will be 59? Okay. So if you look
Angle
at
Angle A will be 72 and D be 59.
okay, let's see. So I have A is 72 and the opposite, which is C, is also 72. And then angle D and B, which will be equal, they will be 59. Okay. Okay, so that is all. Okay, that is all for all the rules of circle theorem. Anyone has any questions? Any comments?
No.
Okay, so like I said, the more questions you do, the more better you get at identifying what rules are in which circle. You become more alert lah. Okay? Okay, if you have no questions, then that is all for today. I will post questions on Edmodo. Please try. Okay?
Okay.
Yeah, thank you, class.
Thank you, Cho.
Thank
Thank you, Miss Sharina. Bye-bye.
you. Bye.